Okay, so welcome back to all of my dear viewers and friends. So today we are going to discuss a very important topic of community medicine. Not only for your examination point of view, but also they are very important in your day-to-day lives. Because in your day-to-day lives, no, you in so many incidents in which there are you see that in your surroundings having lots of contaminated water and you suffering from this contaminated water illness. So with the knowledge of this purification of water, we can uh, maintain your good hygiene and make your water safe for drinking. So without any delay we can start the topics. So here on board you can see that we are going to discuss chlorination. So what is the meaning of chlorination? Chlorination means simply addition of the chlorine or the chlorine compounds. So in water, what are the permissible level of the chlorine? In water, the permissible level of chlorine is the zero point 0.5 to zero point 0.7 milligram per liter. What I am telling, zero point 0.7 to point, not zero point 0.7, first 0.5 to zero point 0.7 milligram per liter. So what are the use of chlorine? Chlorine mainly they kill basically it is act as a disinfectant. It kill the bacteria and most of the virus present in the waters and remove most of the impurities present in waters. So now the question is arise, what are the method of chlorination and what are the step of chlorination? So basically there are two method of chlorination. One is we adding chlorine gas directly into the water with the help of a apparatus, and the name of apparatus is Patterson chloronome. So this Patterson chloronome apparatus used in a developed country for the addition of chlorine gas directly into the waters. In India and most of the developing country, we add bleaching powder which contain almost 33% chlorine. So these are the two methods by which we can clean your water or make the or make your water free from the pathogens. So next step is how we do chlorination. What are the steps of the chlorination? So the first steps of chlorination is we have to calculate the chlorine demands, and for the calculation of the chlorine demands we use a apparatus, and the name of apparatus is the Horrocks apparatus. So what is this Horrocks apparatus and how this Horrocks apparatus help in calculation of the chlorine demands? So in Horrocks apparatus they contain 6 tubes having a capacity of 200 ml with iodine, starch and spoons and some others materials are also present in it, but mainly they are the one is the 6 tubes and the starch iodide. So how with the help of this apparatus we can calculate the chlorine demands? We first fill all these 6 tubes with waters, and after filling all these 6 tubes with waters, I mean what sample waters, we add bleaching powder in a increasing fashion. I mean in first tube if we add 1 spoon of the bleaching powder, in next tube we add 2 spoon of bleaching powder, in third tube we add the 3 spoon of the bleaching powder. So this is the increasing fashion of the increasing fashion of adding bleaching powder. We add bleaching powder in all these 6 tubes in a increasing fashion. So after adding the bleaching powder we wait for 1 hour, and this 1 hour's waiting duration is called contact period. So what happens during this contact period? During this contact period, the bleaching powder release its ions, or one of the effective ions of the bleaching powder is the hypochlorous ions that kills almost 70 to 80% bacteria and remove the impurities. The second less effective ion is the hyponitrite ion. They are also responsible for the killing of bacteria and removal of impurities. So during this 1 hour period, now bleaching powder first release the free ions, I mean hypochlorites ion and the hypochlorous ions. So this hypochlorous ion, mostly hypochlorous ions, they kill the most of the bacteria present in the samples and remove almost all the impurities. So after this 1 hour periods, the amount of chlorine required, for the removal of impurities and the killing of bacteria, this amount of chlorine is called chlorine demands. In mathematically, how we calculate the chlorine demands? For mathematically calculation of chlorine demands, we subtract the chlorine added minus residual chlorines. What is this residual chlorines? After addition of chlorine, some amounts of free chlorines are present in water. So this is called a residual chlorine. Residual means the amount of chlorine that left in water. Generally, the residual chlorines range is 0.5 to 0.7 milligram per liter. So here one point we try to focus, this chlorine demands is not equivalent to the amount of chlorine we added. This chlorine demand is a difference between the amount of chlorine added and the residual chlorines. And what these chlorine demands do? These chlorine demands remove all the impurities and the killing of the bacteria. So this is the role of chlorine demands, or the mathematically we can calculate the chlorine demands by a difference between the chlorine added and the residual chlorines. So after discussing this all about the chlorine demands and the contact period, then next step is we add a starch iodides. Points to be noted: we add a starch iodide not at the time of addition of bleaching powder. We add a starch iodide after 1 hour, after the contact period, not at the time of addition of bleaching powders. So after the 1 hour, the contact period, when we add this starch iodide. So in basically why we add this starch iodide? We add a starch iodide to check which samples contains residual chlorines, because the sample which contain the residual chlorines, they turn into the blue colors. So the purpose of adding this uh, potassium iodide or the starch iodide to checking the sample which samples contain a residual chlorines, because ultimately we have to leave the residual chlorine at a range of 0.5 to 0.8 milligram per liter. So first we have to identify which samples contains a residual chlorine. So for identification which samples contains the residual chlorine, we add the starch iodide, and the sample which turn into the blue color indicate that these samples contain a starch, these samples contain residual chlorine. But the point to be focused is that this residual, this potassium iodide that we add, it is a qualitative test. It only tells that which samples contain the residual chlorine and which samples contain not residual chlorine. It not tells the amount or the concentration of the residual chlorines, but for now we requirement of the concentration of residual chlorines in a samples. So for this we do another test. What is the name of this another test? We using chloroscopes. Fluoroscopes basically they work on two tests. One is the toluidine test and another is the toluidine arsenitide test. So with the help of this test we can quantify the data that which samples contains how much amount of residual chlorines. This toluidine test they detect both combined chlorine and the free chlorine simultaneously. So this is not too much useful. Our most useful in this condition is toluidine arsenide test. So this toluidine arsenitide test, they detects both combined and the free residuals chlorine in separately. So these tests are most effective in the method of chlorination. So with the help of fluoroscopes, we can detect the concentration of residual chlorine present in these samples, and we ensure that the concentration of residual chlorine present in sample in a range of zero point 0.5 to zero point 0.8 milligram per liter. So what happens if any sample their concentration is less than zero point 0.5? In case of less than zero point 0.5, we go for the rechlorination, and if the sample they having a range beyond the zero point 0.8 milligram per liter, then in that condition, this it can make water unsafe for drinking. They some unpleasant taste. So if the water having unpleasant taste, the people are not interested to drink such water. So we ensure that the chlorine range, residual chlorine range are lies in between the zero point 0.5 to zero point 0.8 milligram per liter. So this all about the method of chlorination, and now we go for the reading section. In reading section, we start. Chlorine is the most important constituents of water because they are responsible for the killings of bacteria and removal of all the impurities. Same things are written here. Permissible limit is the 0.5 to 0.7 milligram per liter. Method of chlorination: adding chlorine gas directly into the water with the help of apparatus Patterson chloronomes. The second thing is, in India we commonly use adding bleaching powder content 33% of the chlorine. Steps of chlorine: detection of the chlorine demands with the help of apparatus called Horrocks apparatus. 6 tubes containing capacity of 200 ml with potassium iodides. We add the potassium and we add the bleaching powder in an increasing concentration. First we add 1 spoon, then 2 spoon, 3, 4, 5, 6, like that. So the same things are written here. Add bleaching powder one by one in all tubes in an increasing order. Wait for 1 hour duration per contact period. So during this period, bleaching powder release hypochlorous ion and the hypochlorite ions that kills all the bacteria and removes other impurities. And the amount of chlorine required for this purpose is called what's chlorine demands, which is mathematically equal to the chlorine added minus residual chlorines. So after the contact period, we add a starch iodide that detects the presence or the absence of residual chlorines. If the residual chlorine is present, so blue plus. For quantities, we go for the fluoroscopes. In water, the chlorine residual range of the chlorine in water is 0.5 to 0.8 milligram per liter. Fluoroscopes add on the two tests. One is the orthotolidine test. It can detect both combined and the free chlorines but simultaneously. Another is the orthotolidine arsenitide test. It is the best because it can detect both combines and the free chlorine separately. One of the important point is the hypochlorous ions having a more strength of killing bacteria, 80-85% having a strength for killing the bacteria. Then hypochlorites less effective, 10 to 15%. So this is all about the method of chlorination. I hope you can understand the lecture. See you in next video.